Okay, welcome to my YouTube channel. In this video, we'll be looking at electronic configuration. Electronic configuration. So, what is electronic configuration? Electronic configuration refers to the arrangement of electrons in an atom's energy level or orbital. So, when you see the word electronic configuration, your mind should go to arrangement of electrons. And these electrons are arranged in the atom's energy level or orbital. So, electronic configuration simply refers to the arrangement of electrons in an atom's energy levels or orbital. It is the arrangement of electrons in an atom's energy level or orbital. So, electronic configuration is all about arrangement of electrons, and the electrons are arranged in the energy level or orbital. So it is usually represented using a notation that includes the energy level shell. So it is represented using a notation that includes the energy level shell and the number of electrons in each orbital. And we're going to look at this as we progress. So in electronic configuration of elements, there are four things that you must look at. One is that you must know the atomic number of the element or the atom you want to configure. So for you to write out the electronic configuration of an element, you have to know this. They know the atomic number of the element or the atom. Then secondly, you must use Aufbau principle when you are writing out the electronic configuration of an element. And Aufbau principle states that electrons fill the lowest energy level orbital, before moving to the higher energy orbital. So this is simple. Aufbau principle simply states that electrons will first of all fill the lowest energy orbital before it will not progress before filling the higher energy orbital. So the filling of the orbital is from the lowest energy orbital to the higher energy orbital. This is what Aufbau principle is all about. So when you are configuring an element or writing out the electronic configuration of an element, the lowest energy level or the lowest energy orbital must be filled first before you move to the higher energy orbital. So these are the different orbitals in accordance with their energy level. So if you want to configure an element, you will have to fill the 1s orbital first before moving to the 2s orbital, before you progress to the 2p orbital, before you progress to the 3s orbital, 3p orbital, 4s orbital, 3d orbital, 4p orbital, 5s orbital, 4d orbital, and 5p orbital, and so on. So there is something that you must know in this energy level. The first orbital is the 1s orbital, and an s orbital will carry a maximum number of 2 electrons. So then we have the 2s orbital, then the 2p orbital. There is no 1p orbital, so 1s, 2s, then you move to 2p. So from the 2p, you can now go to 3s, 3p. Then from the 3p, you go to 4s. 4s will usually come before 3d. So you must note this transition here. 4s will come before 3d. So after 3d, you will now have your 4p. After 4p, you will have your 5s, not 4d. Your 5s will come before your 4d. So note the transition here as well. So this is Aufbau principle of filling an electron. The idea here is that electrons fill the lowest energy orbital before moving to higher energy orbital. Then you must always take note of Pauli exclusion principle and Hund's rule. There is a separate video where I explained Albor principle, Pauli exclusion principle, and Hund's rule. So for more understanding, you can go and watch the video on that. Then the fourth thing that you must do when you are writing out the electronic configuration of an element is that you must keep track of the electron count. So as you are configuring the element, you are keeping track, you are noticing or keeping note of the electron count. Very important. So these are the four main things that you must consider when you're writing out the electronic configuration of an element. Number one, I said you must know the atomic number of the element or of the atom. You must use Albor principle. That means you must fill the lowest energy orbital with electrons first before moving to the higher energy orbital. Then you must take note of Pauli exclusion principle and Hund's rule. Then keep track of the electron count as you are configuring. So let's take for instance this classwork. Write out the electronic configuration of sodium. So just as we've rightly explained before, in writing out the electronic configuration of an element, there are four things or four factors that you must take note of. Number one is to know the atomic number of the element, to know the atomic number of the atom. So this is sodium, Na, and sodium has an atomic number of 11. How did I know? From the periodic table, it is the number 11th element, and so the atomic number is 11 here. So that tells us that the atomic number of sodium is 11. So we are considering 11 electrons. 11 electrons. And from this, from what we've learned before in the previous page, that after knowing the atomic number, you want to use Albor principle. And the Albor principle states that electrons fill the lowest energy orbital before moving to higher energy orbital. So, and these are the orbitals. So the orbitals we are considering 1s orbital. After 1s orbital, we move to the 2s orbital. After 2s orbital, then 2p orbital. After 2p orbital, then we have a 3s orbital. After 3s orbital, we have the 3p orbital. After the 3p orbital, you now have your 4s orbital. After the 4s orbital, you now have your 3d orbital. But we're going to stop here because we are considering 11 electrons. Then one thing that you must know here as well is that the s orbital, the maximum number of electrons that can occupy the s orbital is 2, while the number of electrons that can occupy the p orbital is 6. The electrons that can occupy the d orbital is 10, while the maximum number of electrons that can occupy the f orbital is 14. So we are considering 11 electrons here. So we'll fill them starting from the lowest energy level until we exhaust these 11 electrons. So I have 1s. The maximum number of electrons that can occupy this s orbital is 2, 1s2. So I've removed 2 electrons from these 11 electrons. I will be left with 9 electrons. Then the next orbital is the 2s orbital, which will carry a maximum electron of 2. So this is 2s2. I will now be left with minus 2. That will be 7 electrons. Then the maximum number of electrons that can occupy this p orbital, the next orbital is the p orbital, is 6. So plus 6 will give me minus 6 will give me 1. So I'm not left with 1 electron. Then 3 is 1. So 2 plus 2 is 4, 4 plus 6 is 10, and 10 plus 1 is 11. So this is the electronic configuration of sodium. In configuring an element or an atom, you must know the atomic number. Use Albert principle that states that electrons will fill the lowest energy level orbital before moving to a higher energy level orbital. Then you must also keep track of the electron count as you are carrying out the configuration.